Okay, welcome back to my fourth and final installment of exponential logarithm equations. This is part 4. So now what I'm going to do is I'm going to give us several equations that are dealing with logarithms, dealing with the base e, and dealing with the natural logarithm as well. Okay, so first, in solving any of these, there's 3 basic steps I want us to look at. First of all, can I multiply or divide anything? My second step is I want to look and see, okay, if I have a logarithm or a 10, they are paired up with each other. The same thing with ln is paired up with e. And finally, my third step is we need exponents. So if we don't have an exponent, we're going to make it an exponent. So let's take a look at the first example. Look at my 2. I can get rid of this 2 right here by dividing it. So that's my step 1. So that leaves me with log 3 minus x equals 0.5. Because 1/2 is 0.5. Now look at my second step. What's paired with log? Well, in this case, it's going to be this 10. And now I'm looking at step 3. Do I see exponents? I do not see exponents in this one. So what I want to do on this one is I want to make the orange exponent. So I'm going to say right here, I'm going to make this right here and this right here exponents. Let me erase this. So what did I say is paired up with log? It's 10. So 10 is my base. My log 3 minus x is my exponent. And I'm going to do the same thing with my 0.5. I'm going to make my 10 my base. 0.5 is my exponent. This frees up because these make a 1. So 3 minus x equals, and this brings down. So 3 minus x equals, okay, now the common mistake on this one is 10 times 0.5 is 5. That's not what that is. 10 raised to the 0.5 is what we're looking for, and that should give you 3.1623. So to carry this out, what I want to do is I want to subtract. I want to subtract 3 on both sides, and I get negative x equals 0.1623, and then you can basically treat that as a negative 1 to divide. So what happens is now is x equals negative 0.1623. Now let's take a look at number 2. So I want you all to look at number 2, and I want you to think about the 3 steps that I showed us in step number 1. So what are those 3 steps? Well, I'm going to put this again. We'll put this in a little box. My first one, can I multiply or divide? My second one is, okay, log paired up with 10, ln paired up with e, and finally I'm looking for exponents. So, I don't have anything in front of this e, so I know I cannot divide or multiply anything. So my next thing is, okay, what is paired up with? I see my e, so that has to be ln. Do I see an exponent? In this case, yes I do. It's the 4x. So what I'm going to do is I'm going to put ln as paired up with e. If I do it to one side, I have to do it to the other. And ln of e is 1, so that exponent comes down to 4x. So I'm left with 4x equals ln of 18. Then to get rid of this 4, we'll divide. So make sure you could say ln of 18 in parentheses, or just hit enter, divided by 4. And in this case, x equals 0.7226. Now I'm going to use the same problem, except now I'm going to put a 3 in front of the e to the 4x. Because now, if I'm looking at my steps, now I can divide. And I'm using the exact same methods now. So on this one, what I would do is I would go ahead and divide everything by 3. This gives me e to the 4x equals 6. Just like the previous one. E is paired up with ln. I have an exponent, so I do not have to make it an exponent. ln of e to the 4x, ln of 6. ln of e's makes the 4x bring down because ln of e is 1. 4x equals ln of 6. Divide by 4. So ln of 6 is in parentheses, divided by 4. And you get x will come out to be 0.4479. Now I've got this ln of 156x equals 2.32. Can I multiply or divide anything? No, because there's nothing in front of the ln. Now, what is ln paired up with? It's paired up with e. Now, do I see an exponent? In this case, I do not see an exponent. So I'm going to make the ln of 156 the exponent. The e is the base. And then over on the other side, e is the base, and the 2.32 is the exponent. Now, what happens is the e and the ln, they cancel each other out, and what's left is 156x equals, now the 2.32. Now, when you take the e of that, if you, on your calculator, if you hit your second button and then ln, it gives you e to the raised power, and just type in 2.32, and you hit enter on that one. So I come out to be 10 e to the 2.32 comes out to be 101757. Then I'm just going to divide by 156. This case, it's going to be a small number. It's going to be 0.0652. What happens when you have 7e to the 3x plus 10 equals 42? Well, looking at my 3 steps, first of all, I can get rid of the 7 by dividing, so that's my step 1. So by doing this, I get e to the 3x plus 10 equals 6. What is paired up with e? That is ln. And then, since I have an exponent, I don't need an exponent, so I'm going to put ln in front, or be in front of the e, ln in front of the 6. So that makes that 3x plus 10 equals ln of 6, which comes out to be 1.7918. From this point, I'm going to subtract 10 on both sides. I get 3x equals negative 8.2082. Then I'm going to divide by 3. X is going to be negative 2.7361. Now finally, this is where this all comes down to as well. Okay, so let's just say, for the sake of argument, we were given a table or a chart, and in our calculators, we would have to hit stat and edit and put our L1 values, L2 values in, and then hit stat and calculate. option 0, exponential regression, and lo and behold, it spits out an a equals 3 and a b equals 4. So from this, what we need to do is come up with an equation. And then we're going to find this this y of x equals 36. So just a recollection of exponentials, it's going to be a to the b to the x. That's the format. So right over here, y equals a is 3, b is 4 raised to the x. But then the yx equals 36 is a second y value. Now another side note too is we also may recall making this y1, y2, and then going up and hit second and trace on our graphing calculators. And when you do that, you would do option number 5, which is intersect. So when we intersect these, that means you hit enter and it will give you a bunch of guesses. So it will say curve 1, curve 2, guess. Then when you hit enter, it gives you an intersection point, and that's how we used to find x. Well, in this case, now I want to show us how to do this by hand. So what we're going to do is we're going to take our first equation, the 3 times 4x to the x power, we're going to set it equal to the second one, which is just 36. Now we're going to still use our 3 steps to solve. So in this case, look at what's in front of the base, in front of the 4. It's a 3. We can divide it. So now I've got 4x equals 12. Now using our power rule, bring that down. I'm going to say x log 4 equals log 12. My final step is I'm going to take log 4 and divide it. Put them in parentheses. And lo and behold, x equals 1.7925. Well, I hope this has been helpful. Thank you for listening, and have a great day.